Hello, my name is Angie Diaz, and my project is in phytoremediation of nutrient pollution using basil and microorganisms in South Florida. Introduction. South Florida faces significant water pollution challenges due to excessive nutrient runoff from agriculture, urban development, and wastewater. Excess nitrogen and phosphorus in waterways contribute to harmful algal blooms, fish kills, and declining water quality in ecosystems like the Everglades, Biscayne Bay, and Lake Okeechobee. Traditional wastewater treatments are constantly prompting interest in phytoremediation as an eco-friendly alternative. Why basil? Fast-growing in warm, humid climates like South Florida and absorbs nutrients efficiently. Used in agriculture and hydroponics, works in synergy with beneficial microbes for enhanced bioremediation. Microbial support and bioremediation. Nitrosomonas and Nitrobacter convert ammonia into nitrates. Chlorella vulgaris absorbs excess nitrogen and phosphorus oxygenates water as well. Problem statement. This study explored how basil and beneficial microbes like Nitrosomonas, Nitrobacter, and Chlorella vulgaris can improve water quality in South Florida by reducing nutrient pollution in lakes, rivers through a process known as phytoremediation. Objectives. This study aims to evaluate basil's role in nutrient removal, assess the ability of basil to absorb excess nitrates and phosphates from contaminated water, analyze the effect of microorganisms, investigate whether adding Nitrosomonas, Nitrobacter, and Chlorella vulgaris enhances nutrient removal efficiency, compare different treatment methods, test and compare basil alone versus basil bacteria and algae to determine the most effective bioremediation strategy, apply findings to South Florida's water issues, explore how this bioremediation system can help reduce nutrient pollution in areas like the Everglades, Lake Okeechobee, and Biscayne Bay. Hypothesis. Basil will effectively absorb excess nitrates and phosphates from contaminated water, improving water quality. Secondary hypothesis. The combination of basil with beneficial microbes, Nitrosomonas, Nitrobacter, and Chlorella vulgaris will enhance nutrient removal efficiency compared to basil alone. Methodology. Prepare contaminated water samples. Create synthetic wastewater with a mixture of controlled nitrate, ammonia, and phosphate. Additionally, collect real-world nutrient-rich water from local sources like the Everglades, Lake Okeechobee, and Biscayne Bay. Set of treatment groups. Control group, contaminated water with no treatment, basil alone, basil plants in nutrient-rich water, basil plus bacteria, basil with nitrosomonas and nitrobacter, basil plus algae, basil with chlorella vulgaris, basil plus bacteria plus algae combination treatment. Monitor over 14 days, and it will be conducted over three trials, so a little bit over a month. Measure nitrate, ammonia, and phosphate levels daily. Record basal growth, height, root length, biomass. Track pH and dissolved oxygen levels. Data analysis. Compare nutrient removal efficiency across treatments. Evaluate the statistical significance of plant microbe interactions. Determine the most effective bioremediation approach. Data collection. Parameters measured daily. Nutrient levels, nitrate concentration, ammonia concentration, phosphate concentration, basal plant growth metrics, height, root length, biomass, wet, dry, weight in grams, water quality indicators, pH level, dissolved oxygen concentration, temperature, microbial activity monitoring, visible biofilm formation, algal growth density. Expected results. Nutrient reduction trends. Basil alone, the control, will absorb nitrates and phosphates, but may have a limited impact on ammonia removal. Basil plus bacteria, Nitrosomonas nitrobacter, will enhance nitrogen removal through microbial nitrification. Basil plus algae, Chlorella vulgaris, will contribute to additional nutrient absorption and improve oxygen levels. Basil plus bacteria plus algae will show the highest nutrient removal efficiency combining microbial nitrogen cycling with plant uptake. I hypothesize this just to show the highest removal efficiency because basil with bacteria and algae form this positive feedback loop where where the bacteria turns the nitrate and phosphate and ammonium from the water into nitrite, and then it turns it into nitrate, and then the nitrate is used by the basil and the algae to turn it into oxygen, which is then used by the aerobacteria, Nitrosomonas and Nitrobacter, to repeat the cycle all over again. Water quality improvements. Reduce nitrate, ammonia, and phosphate levels over 14 days. Stable pH and increased dissolved oxygen levels due to microbial and plant activity. Clearer water and treatments with bacteria and algae compared to the control. Basil growth response. Faster growth in basil plus microbial treatments due to improved nutrient availability, increased root length and biomass, indicating efficient nutrient uptake. Significance of results. Confirms the potential of phytoremediation with basil and microbes as a sustainable water treatment method. Provides insights into microbial plant synergy for nutrient pollution control in South Florida water bodies. And these are my citations. Thank you.